Lesson 1-7 Function. Determine whether each relation is a function. You have domain and you have the range. Now, for relation to be a function, it must be one-to-one function, we call it, which means one domain corresponds to exactly one range. So this one right here, one domain, one range, one domain, one range, one domain, one range, one domain, one range. So this is a one-to-one function. So this is the answer to this one is function, or just simply write yes. Function, or just write yes. Now this one right here, one domain, one range. But number 4 right here, one domain, but you have two ranges, no? 4, you have 5, and you have 6. So this is not domain. You just simply say no, or you can write not function. Now for a graph like this, we're using a vertical line test. When you draw a vertical line to cut to intersect the graph, or cutting the graph, if the vertical lines intersect the graph at exactly one point, then the answer here is a yes, it is a function. But when you draw a vertical line test and the line passing the graph at 2 points or more, in this case 2 points, the answer here is no, not function. Let me repeat. When you draw a vertical line test to intersect the graph, if a vertical line intersects a graph at exactly 1 point, it is a function, or yes. But when the line passing through the graph at 2 points or more points, the answer is a no. How about if it is given in a coordinate pair like this? Well, same idea, like this number 1 and number 2, you're looking at the domain first. Is there a domain that have the same value? You have 5, you have 6, you have -8, you have 0. When domain doesn't have the same value, 5, 6, -8, and 0, they are not the same value, then your answer is yes, or you can write this is function, or just simply write yes. Got this one together, you have 4, 3, -2, and 4 again. See that you have 4 here correspond to 5, and you have 4 here correspond to 7. So you have two domains that are the same but different range. So you have 4 has 5, and 4 has 7 also. So this is a no, not function. This is horizontal line, the answer also yes, function. This is a vertical line, undefined slope vertical line, the answer to this one is no, not function. This is the slant line, so the answer is yes, function. This is also slant line. When you move this one to the other side, you will have this as 3y, 3y equal to 3x, or y equal to x. So it's also a slant line, so which means it is also function. Yes. Now let's continue furthermore to the other problem with this section. And number 10. Right, number 10. Look at the function. We have function f of x equal to -x minus 3, and g of x equal to x squared plus 5x. Now let's try to find each of this value. Alright, so looking at function f first, f of -2, so which means right here -2 represent the x value. So right here, so -2 times x, but your x here is -2. So this is the x value. So -2 times -2, you have positive 4. 4 minus 3, you have 1. Number 11, 7, f of 7, so which means right now the value of x becomes 7. So -2 times 7, you have -14. -14 minus 3, so you have a -14 minus 3, you have -17. Now for g, -3, so g of -3, looking at the g function, so x is -3. So x squared, so -3 squared, you have 9. plus with negative 3 plus 5 multiplies with this is negative, so negative 3. So you have 9 minus 15. Minus 15, that will give you negative 6. Now number 13, g of 5. So right now x becomes 5. So we have 5 squared is 25 plus 5 times 5 is 25. That will give you, this is as 50. Number 14. So right now the x value right now become 4y. So which means you need to do just replace the x value with the 4y. So 2 times x, but your x in this case is 4y and minus 3. And simplify it. Negative 2 times 4y, you have negative 8y and minus 3. Number 15. Now in number 15, g of negative 6m. So right now the x value has become negative 6m. So you replace x with negative 6m. So for g you have x squared, but x here is negative 6m squared. Plus 5 times x, but your x here negative 6m. Like this. So this one negative 6, so negative 6 times 6 is 36 m squared, and this is plus times minus become minus 30 m. So you have this one 36 m squared minus 30 m. 16. Number 16. Right now your x value represented by c minus 5. So this is negative 2 times with x, but your x right now c minus 5. So c minus 5 and then minus 3. This is the minus 3. And let's simplify this. You have minus 2 times c, you have minus 2c. Minus 2 times minus 5, you have plus 10, and you minus 3. From here you simplify it, you will have this as minus 2c. And then 10 plus 3. 10 minus 3. You have this one as 7. Number 17. Number 17 still working with f of function, f of x function. So in this particular case, your x value is r plus 2. So you have negative 2 times x, but your x here is r plus 2. So r plus 2, and then you minus 3. Let's simplify this. 2 times r, you have 2r. And then minus 2 times 2, you have minus 4, and then you minus 3. Simplify this one, you will have this as minus 2r minus 7. Number 18, f of d, but this is multiply everything. I will work with the 5 later, but work with this one inside the bracket first. So right now your x is being substituted by the d. So you have minus 2, instead of put x, you put d here, in this case d. And then you minus 3. And then this function is multiplied with 5. This is coefficient here 5, multiplied by this function. So to simplify this, 5 times minus 2d, you have minus 10d. And 5 times minus 3, you have minus 15. Last number 19. Now number 19, g of n, I will work with this coefficient later, but I will work inside the bracket first, g of n. So right now your x value being represented or being substituted by letter n. So you put x squared, right now you put n squared plus 5 and n as well, and that function is multiplied with 3. So from this, let's simplify this one. 3 times n squared, you have 3 n squared plus 3 times 5, you have 15 n. Lesson 1-8, interpret graphs of function. Identify the function graph below here as linear or non-linear, then interpret the end behavior of the graph. Okay, now linear and non-linear first. Linear is a straight line, non-linear is a curve. So this one right here is a curve, so this is non-linear. So that's our first answer to our first instruction, non-linear. This is. Now after that, then interpret the end behavior of the graph. Okay, now this is about vehicle depreciation. You buy a vehicle, and as you can see the graph, as it getting older, its price begin to drop. So to interpret this in simpler term, so we can see that as the number of years increase, the value of the vehicle decreases. See, as the number of years increases, the value of the vehicle decreases. Let me write this for you. As the number of years increases, the value of the vehicle decreases. Okay. Number 2, lawn mowing service. You have this is straight line, so this is linear. Now looking at the trend of the graph first. So this is the number of weeks, time in weeks, is the profit in dollars. So as you can see, it's starting from negative and all the way go up to positive profit. So as you can see, as the number of weeks, this is the time, as the number of weeks increases, the profits will increase. See, this as the week increases, the time in weeks, we can say as the time increase, but I would prefer to be specific. As the number of weeks increases, the profit will increase. So as the number of weeks, as the number of weeks increases, the profits will increase. Number 3, this is about company advertising. Well, this is a curve, this is non-linear. And then as you can see, the profit being made, and then go up to the peak and then drop down as the number of advertising increases. So this is the advertising expense. This is the profit being made. This is the expense. So you expend more, the profit will going down. So to put this in simpler term, as more money is spent, so this is more money, this is the money spent on advertising. So as more money is spent on advertising, the profit will decrease, so that the company is losing its money. See that? So when you start to spend more on the advertising, the profit is begin to drop until the company is losing money. You have a negative profit here, negative budget here, so the company is losing money. So let me write this one for you. As more money, so you put as more money is spent on advertising. How do we spell advertising? The profit will decrease, so that the company is the profit will decrease. Will decreases. Will decrease. Saying just decrease. So that the company. So that the company is losing money. Let's move on to our last three numbers. Okay, this is about website traffic. This is the trending going up here. Number of hits, time in months. So this is a curve. This is non-linear. So as you can see, the times begin to increase and the number of hits also increase. So to put this in simpler term, which means that as the number of months increases, the number of hits also expected to continue to increase as well. Or you can say like that, or you can just say as the number of months increases, the number of hits also increases. As the number of months increases, the trending of hits, the hits trending, this is the number of hits trending, the number of hits also increases. You can say it's also expected to be increased or to be continued. Number 5 is about medicine concentration. Okay, this is nonlinear. And then as you can see, its concentration when as the time goes on, as time increases, seems like the concentration begin to drop down until there is none left, at 0, 0, no more concentration at all. So to write this in simpler terms, so you can write this one as the concentration of medicine become less and less until there is no more. As the time increases, or as the number of hours increases, as the number of hours increases, the concentrations of the medicine become less and less, or of the medicine drop down. You can say like that. not drop down, sorry, the medicine begin to drop, or you can say as the number of hours increases, the concentration of the medicine becomes less and less until there is none left. Until there is none left. Last number in this section, number 6, is about the pendulum swing time. This is the length of it. This is the swing time of the pendulum. Okay, as you can see, the shorter the length, the shorter the swing time. But as the length increases, the times also increases as well for it to swing. So this is a curve. This is also non-linear. So that let's translate this one here. This is for a swing. So as you can see, as the pendulum gets longer, the length increases or it gets longer. So as the pendulum gets longer, so I'm not going to S, get longer, the time it takes to complete one full swing also increases. The time it takes to complete one full swing increases. You can see from the graph, if the length is short, it takes shorter time to complete a swing, one swing. But as the length getting longer, you see that the time begin to increase as well for it to complete one swing. So basically you can see it from here. So as the length of pendulum increases, the time it takes for full swing also increases as well, based on this graph right here. Increase in length, increase in time. So this is all of our lesson 1-8.